Alright, hi everyone. Let's continue with our data structures and algorithm series. Today we are going to see another intermediate sorting algorithm, that is quicksort. Let's see how exactly quicksort works. As per the definition, in quicksort we select one element at a time, calling it a pivot, and then moving all smaller elements to the left and all larger elements to the right of the pivot. I will repeat one more time. In quicksort, we have to select one element at a time, and then we have to move all the smaller elements smaller than the pivot element to the left hand side and the larger elements to the right hand side. In this way, the pivot element will be sorted. We do not care about the order of smaller and larger elements. All we care about that pivot element is correctly positioned in the sorted order. Let's try to understand this with an example. As you can see, I already have an example array here consisting of some 7 elements. Let's see the working of quicksort visually first, and then we will write code for it. So as per the definition, let's select an element and call it pivot. So for simplicity, I will be selecting the first element as my pivot. Right now it is selected. Now if you remember the definition, we have to move all smaller elements to the left and all larger elements to the right. So let's try to do that. So the smaller elements are 0, 2 and 1, right? Let's move them to the left. And the larger elements are 6, 8 and 9. We will move them to the right. So now you can see the pivot point is now correctly positioned. All the smaller elements are in the left hand side and the larger elements are in the right hand side. Simple, right? Now we will repeat this process until the whole array is sorted. So first we will try to sort our left hand side and then we will try to sort our right hand side. So now we will repeat the step of selecting pivot point. For simplicity, I will mark 0 as my pivot point. Now remember, we have to move all the smaller elements to the left and larger elements to the right. Now if you compare 0 with 2 and 1, because we have to sort our left hand side now, so no need to compare it with 6, 8 and 9. We will only compare it with 2 and 1. No element is smaller than 0. So 0 is correctly positioned already. So we will mark 0 as sorted. Now let's select next element as my pivot point, which is 2. Now we have to move the smaller elements to the left, and the smaller element is only 1, right? Because 0 is already there and we are not comparing it again, but 1 is still there. Now we have to move the smaller elements to the left, right? And 1 is smaller. So we will move 1 to the left of 2, and now you can see 2 is sorted. Same step we need to do for 1 as well, but since we have no more elements to compare, 1 is also sorted now. So now we can say the left hand side of the array is now sorted. Now we will repeat the same steps for the right hand side of this array, which means my pivot point now will be 6. Right? Now we have to move smaller elements to the left of 6, but all the smaller elements are already in the left. There are no more elements that can be moved to the left of our pivot point. So 6 is already sorted. Same steps we will be doing for 8 and 9, but since we have no smaller elements, so there will be no shifts, we can consider 8 and 9 as well sorted. So see, that's how quicksort works. Now let's discuss how exactly we should select our pivot point. In our previous example, we selected pivot point for simplicity. We picked the first element as our pivot point. But you have to consider this as well when you are selecting your pivot point. The runtime of your quicksort depends on how we select the pivot point. Meaning, how long your quicksort algorithm will take to sort the given data will depend on how you are selecting the pivot. Ideally, we should pick the median value of the dataset as our pivot so that we can have equal number of elements in the left hand side and the right hand side. In that way there will be less operations and quicksort will work faster. But for simplicity, we will pick the first element as our pivot point because it will not be an easy task to find the median value of the dataset because we don't know where this median value is located in that array or the given data. So for simplicity, we will always pick the first element as our pivot point. Alright, so now we have seen the theory of quicksort and how quicksort works. Now we will write code for it and see how this sorting algorithm works in action. First, let's discuss the pseudocode and then we will write the actual code for it. So I will be dividing my code into 2 parts. The first part will cover the rearranging of smaller elements to the left hand side of the pivot point and the larger elements to the right hand side of the pivot point. Alright, so the first step is let the first element as your pivot. and then store the pivot index in a variable. Now this pivot index later on, after completing all the iterations, will tell us where we need to put our pivot point so that we have all the smaller elements to the left hand side and larger elements to the right hand side. So keep that in mind. And then next step is iterate over the rest of the array elements and compare pivot with each element. If it is larger, then we will increase our pivot index by 1 and swap it with the current element. This might be sounding a little confusing, but we will understand it better when we will see it in action. And then we will swap the pivot with the pivot index. And after that, we just need to return the pivot index. Alright, now let's quickly jump onto the code sandbox and see this pseudocode in action. Alright, I already have a pivot function here that accepts an array, a start point and an end point. Now according to our pseudocode, the first step is to define the pivot and consider the first element as our pivot. For that, we have to write array start. The second step of our pseudocode is to store the index of our pivot in a variable. So let pivot index equals start. Right, now we have to iterate over the rest of the elements and compare it with our pivot element. For that, we will need a for loop. So for let I equals start plus 1, and I will run until the end. With every iteration, we will increase it by 1. Now we have to compare pivot with the current element. Right, now if you look at the pseudocode, if pivot is larger than the element, then increment the pivot index. So if pivot is greater than array I, we will increase the pivot index by 1 and then swap it with the current element. I will be using ES6 syntax for swapping pivot index with the current element. That will look something like this. So array I, array pivot index. Alright, if pivot is smaller than array I, then we don't need to do anything. We will simply skip on to the next element. After doing the complete iteration, we have to swap the pivot with pivot index. Let's do that as well. We have to swap the pivot. Now remember, pivot is at the 0th index, right, which is at the start. So we will swap array start with array pivot index. This will look something like this. Array start. Cool. And in the end, we have to return the pivot index. Now let's run this code and try to understand what exactly we are doing here. Before that, for our help, I will be adding some console logs here. First log I will add here. Console log. My pivot will be this. I will add here console log pivot index as pivot index, and then before incrementing, another log that will tell us about our current element I, or let's make it more informative, comparing pivot with current element, right? And after swapping, how does our array looks? After swapping, how does our array looks? And in which cases we are skipping to the next element. So I will also type here comparing. Maybe I will just copy this, or maybe I will put it outside, right? It will cover both cases. Alright, and after final swap, I will add another log. That's a lot of logs, but it will help us in understanding how this code is working. So I will put here my array. Alright, I think that's all. that's all console logs we need here to understand this code, but if anything is required I will add another log. Alright, now let's try to run this. I will open the console. Alright, so now you can see I have selected 4 as my pivot, which is the first element, and the pivot index is 0, which is correct. And then according to our pseudocode, we have to compare pivot with rest of the elements. So what we are doing here, comparing 4 with the current element 1, which is actually not 1, this is the index. Let me just modify it. Alright, so comparing 4 with 8, but 4 is not greater than 8, so we will not go inside this block, and simply moving on to the next element, that is 2, right? So comparing 4 with 2, 4 is greater than 2, right? So we will go inside this block, and then we have to increase our pivot index. So pivot index will be incremented from 0 to 1, and then we will swap pivot index with the current element. And now if you see, after swapping, the array something looks like 4, 2, 8, but our actual array was 4, 8, 2, right? Meaning now the smaller element move to the left hand side. This is what exactly this code is doing here, rearranging the smaller elements to the left hand side. So now you know what will happen to the next element. The next element is 1 here, right? So when we are comparing 4 with 1, we know 4 is greater than 1, right? So we have to increment the pivot index, meaning pivot index was 1 previously, but after increment it will become 2, and our array looks something like this: 4, 2, 8 and 1, and then rest of the element. So this is our pivot index right now after incrementing 0, 1, 2, right? And then we have to swap it with the current element. The current element is 1 here. Now if I swap it, it will look something like 4, 2, 1 and then 8 and the rest of the elements. Right now you can see how we are moving our smaller elements to the left hand side, and the larger element will keep on going to the right hand side. Cool, right? Now what happens to the next iteration? The next element is 5 here. Now when we are comparing 4 with 5, it will not go inside this block, simply moving on to the next element, which is 7. Now again 4 is smaller than 7, we cannot go inside this block, moving on to the next element. Again for 6 as well, but the last element is 3 here. Now if I compare 4 with 3, 4 is greater than 3, right? So we have to move inside this block. And now remember, pivot index was 2 previously. Now it will be incremented to 3. I will write the array here. It looks something like this, right? Now pivot index becomes 3, meaning 0, 1, 2, 3. Now here we have our pivot index. Now we have to swap it. After swapping, 3 will come here and 8 will come here. Now you can see all the smaller elements are here. Remember, smaller elements than the pivot point are now here, and all the larger elements than the pivot point are now here. And also we have completely iterated over our array. Now we will move outside this block, and then we will swap our pivot with the pivot index. Now if you remember, the pivot index was 3 in our last iteration, which means after swapping the pivot with pivot index, the array will look something like this. Now you can see all the larger elements are in the right hand side and all the smaller elements are in the left hand side. So that's the working of this pivot function. Now we will use this in our quicksort algorithm to sort our given data. Let's look at the pseudocode of quicksort. So the pseudocode is something like: call the pivot helper on the array, and when the helper returns the updated pivot index, then recursively call the pivot helper on left and right part of the array. Meaning, once you get this part, you have to recursively call the pivot function on left and right part of the array, so that what we have done with 4, we will be doing same for all the elements, which will in the end give us our sorted array. Now let's write the quicksort function. Alright, now we will write a quicksort function that will take array as the parameter, start point that will start from 0th index, and an endpoint. Alright, now since we have to call this function recursively over the left and the right part of the array, we will need a base condition that will basically help us in stopping this recursive call and will help us to not get stuck into some infinite call. The base condition will be like: start should be smaller than the endpoint. right? Because we will be iterating over the array, so we have to make sure we do not go beyond the endpoint, right? Also, if this base condition hits, we will return the array. Cool. Now we need to get our pivot index, which you will be getting from this pivot function, right? So pivot index, I will call the pivot method. It will pass we will pass array, and then we will pass the start point, that is 0th index, and then the end point. Alright, once we call this pivot method, it will separate the left hand side and the right hand side for us. Now we will recursively call the quicksort method over the left hand side, which means we have to pass the array, the start point, and the end point. Now the end point will be pivot index -1. This is our left part, and for the right part we will call quicksort. We need to pass array. Now the start point will be pivot index and the end point will be end. Oops, the pivot index needs to go with +1 because the pivot point or pivot element will be sorted when we call this pivot function, right? So we don't need to include it. We will start with the next element. Alright, I think that's all what we need to do to implement the quicksort. Now I will run this with an example. I will pass this array, start will be 0 and end will be array.length -1. Alright, I will open the console. Alright, you can see the output here. We have 1 2 3 4 5 6 7 8, which means all the elements are now sorted and our quicksort function is working as expected. You can also go through the logs here, which will show you how exactly this code is working, like selecting the pivot and the pivot index and then comparing it with the rest of the elements. And you can see here the final swap which we saw before, right? After this, my left hand side is being sorted again with the same steps, selecting the pivot and then comparing it with the rest of the elements. And once our left hand side is sorted, you can see from here, right, pivot 5, this is from where the right hand side is being sorted now. And you can see selecting each element as pivot one by one, 5 7 etc, and in the end it gives us our final output. You can play around this code, add console logs wherever you think something is not clear, or you can even ask in the comments. Now what you can do, you can try to find out the time and space complexity of it and let me know in the comments. Alright, that's all for this one. Thanks for watching.